Yeah, so this is a question from GATE 2019. The question is, in the circuit shown, what are the values of f for En equal to 0 and En equal to 1 respectively. So I need to find what is the value of f for different values of En and D. Okay, so we have one NAND gate, one NOR gate and NOT gate here. So let the output of NAND gate be O1 and output of NOR gate be O2. Okay, so from the circuit O1 can be given as O1 will be equal to, so we have input enable En and D, right? So it is En dot D bar whole bar. Okay, that is output of NAND gate, and O2, which is the output of NOR gate, it is enable bar, so which is coming here, dot plus D whole bar, that is actually NOR gate, right? So enable bar plus D whole bar, so this is equal to enable dot D bar. Okay, yeah, so we'll see for different values of enable what is this value of O1 and O2. Okay, so I have enable value and I need to find what is O1 and O2 for different values of enable, right? So enable value when En is equal to 0, so according to this is En dot D bar, right? That is O1. So when En is 0, 0 dot D is actually 0, 0 bar is 1, so O1 is 1, and for O2 it is like 0 dot D bar, so it is 0, that is for enable En equal to 0, and when En is equal to 1, O1 is 1 dot D whole bar, that is D bar, and here it is 1 dot D bar, that is D bar. So these are the two conditions. Okay, now we'll see what happens to F by checking this circuit. Okay, I need to find what is F. So when enable is En is equal to 0, O1 and O2, okay, O1 is equal to 1 and O2 is equal to 0, right? So what happens when O1 is 1, okay, it is connected to a PMOS. This is a PMOS and this is an NMOS, right? So what happens when O1 is 1, PMOS will be open. So we can draw this like a switch, open switch PMOS. Here the node is VDD, and here the switch is connected to the point F, and we have bottom NMOS. Now for NMOS, O1 is, right, O2 is 0. So when O2 is 0, what happens? The NMOS is actually open, right? So NMOS is also open, right? So for a PMOS, when input is 1, it is open, and when input is 0, it is closed, right? And similarly for NMOS, when input is 1, it is closed, which means it's like a closed switch, and when input is 0, it is like an open, right? So that's what. So what happens here, the F is neither connected to VDD, neither connected to ground, so it is like a it is like high Z, right? So it is like open, it is not even connected to 1 or 0, so it's like having a high impedance, right? So output F will be equal to at a high impedance. So if I write here F, right, the output is high impedance. Okay, now similarly when enable is equal to 1, what happens? O1 is equal to D bar and O2 is also equal to D bar. Okay, so we'll take first the case when D is equal to 0, which means D bar is 1. So what happens if we see the circuit here, D bar, O1 and O2 is 1, right? So for the PMOS, this is PMOS and this is NMOS and this is F. Okay, this is VDD, this is grounded. So here when D bar is 1, what happens? The so here PMOS will be open, so this is open, and when input is 1 to NMOS, right, it is closed, right? NMOS is closed, so this will be closed like this, right? So what happens? F will be equal to, F is connected to 0. So when D is 0, F is also equal to 0, right? Now similarly when D is equal to 1, what happens? D bar is equal to 0. Okay, so we'll see what happens to F. So again looking back to the circuit, I have PMOS and NMOS, and this is F and this is VDD, right? So when D is equal to 1, D bar is 0, right? So input to PMOS is 0 and input to NMOS is 0. So what happens? PMOS become closed switch. So PMOS is closed and NMOS is opened. So this is like an open. So what happens? VDD, right? F is connected to entirely to the VDD, or this is like F is equal to 1, right? So F is 1. So if you see here, when D is 0, F is also 0. When D is 1, F is also 1. So what is F when enable En is equal to 1? F is actually D. Right? So answer is, when En is 0, it is high Z, and when D is enable is 1, it is D. So answer is B. Yeah, so this is another question from GATE 2019. So the question is the state transition diagram of the circuit shown is. So we have an FSM here and we need to find its state transition diagram. So here this is a D flip flop and the output of D flip flop is Q, and this is a mux controlled by the value of A, right? So if we carefully see here, when A is 0, right, when A is 0, the output here will be the value connected to 0, that is this is Q bar, right? So output will be equal to Q bar. Okay, so what will be D then? So what D will be, so when A is 0, the value of D is here, right? So D will be equal to Q dot Q bar whole bar, right? So here, so what is this? Q dot Q bar is 1.0 or 0.1, right? So it will be actually 0 bar, so it is actually 0 bar, that equal to 1, right? So when A is 0, definitely the value of D will be equal to 1, right? And when A is equal to 1, right, when A is equal to 1, what happens? Whatever the value here, Q comes here, so the output here will be Q. So what will be D? D will be equal to Q dot Q whole bar or Q bar, right? So when Q is 0, the next D will be equal to 1, and Q is 1 means D equal to 0, right? So we have such a circuit and we have one flip flop. So we have two states, that is when Q is equal to 0 and Q is equal to 1, right? And what is D? D is actually the next state, right? So whatever D comes here, that will be the next state coming here, so that is the Q next. Okay, so this corresponds to, so this value corresponds to the next Q next, okay, and this also correspond to Q next. Okay, so depending upon what is the value of A, the Q next will be either 1 or it will be equal to Q bar. Okay, so when we'll take this value, that is when Q is equal to 0 and A is equal to 0, so what happens? The next state, right, Q next is actually equal to 1. So whenever A is 0, the Q next will be equal to 1 itself. So when the state is at Q equal to 0, the next state, and when A input A is actually equal to 0, the next state is actually Q is equal to 1. And similarly, when Q is 1, okay, and A is again 0, Q next is equal to 1 itself. So if it is in state 1, Q equal to 1, the next state will also be equal to 1 when A is 0. So that is what this means. Okay, now next, when Q is 0 and A is 1, what happens? So we know the next state, Q next here is Q bar, right? So when Q is 0, the next state is actually 1, right? So when Q is 0, the next state will be equal to 1 when A is equal to 1, and when Q equal to 1 and A is equal to 1, the Q next is 1 bar, right? So it is 0, which means when Q is 1 then and A is 1, this will come to here, so A equal to 1, right? So this is the so this is the state diagram. So when we see here, answer C is the correct answer. Yeah, so this is another question from GATE 2019. The question is, in the circuit shown, the clock frequency, that is the frequency of clock signal is 12 kilohertz. So here the clock is 12 kilohertz. The frequency of signal Q2 is dash kilohertz. So I need to find what is the frequency of this signal at Q2. Okay, so if you carefully see here, the input to each flip flop will see. So D1 here it is actually, so it's an output of AND gate, and input to this AND gate is, this is Q1 bar and this is Q2 bar, right? So I can say D1 is equal to Q1 bar dot Q2 bar, right? And sorry, or this is equal to Q1 plus Q2 whole bar, right? And what is here at D2? D2 is whatever input from output from first flip flop is given to Q2 or the second flip flop, right? So D2 is equal to Q1, right? So if I write here, so what is this? This is the next state. Whatever D comes here, that is the next state of those corresponding flip flops. So Q1 next is Q1 plus Q2, and here it is q2 next is q1, right? So we'll write the present and next state. This is present state and this is next state. So if present state includes q1, q2 and next state is q1 next and q2 next, right? Yeah, so say initially both q1 and q2 is 0, right? So what is next state? So q2 is definitely whatever q1, right? Whatever is the q1, that will be next state to q2. So this 0 of q1 will be next state of q2, right? So but what happens to q1 next? Q1 next is q1 plus q2 whole bar, that is 0 plus 0, which is 0, whole bar, that is 1. So next state is 1. Okay, this will be the next present state. So 1 0, this will be the next present state. So what is the next state to this? So again q2 next will be same as q1, right? So q2 next is 1, and what happens to q1 next? 1 plus 0 whole bar, or 1 plus 0 is 1, 1 bar is 0, right? So it will be 0 1, and this will be the next present state, that is 0 1 will be the next present state. Okay, so what is the next state to this? So what is q2 next? Q2 next is q1 itself. So this is 0, and what happens to q1 next? Q1 next is 0 plus 1, that is 1, 1 whole bar is 0, right? Now this will be the next state again. So 0 0, and this is same as this, right? So next state will be 1 0, and this will repeat 0 1 0 0 1 0, etc., right? So this is the sequence we can see using this FSM. Now if we carefully see q2 next, the question is to find the frequency of q2 next. So I need to find how this q2 next output varies. So if you see here, the q2 next repeats after each 3 cycles, right? So 0 1 0 0 1 0 and so on, which means the output will be like this: 0 1 0 1, sorry, again 0 1 0, like that, right? This is repeated, and when does this changes? This output changes for each clock cycle, like this. So this is the clock. So this is the clock, and this is q2. Okay, so if you see here, the actual time period of q2, right, t is actually thrice that of tc. So this is the clock signal, right? It will be thrice that tc. So what is the frequency of q2? It is 1 by t, which is equal to 1 by 3 tc, and we know 1 by tc is actually 12 kilohertz, sorry, 12 kilohertz, that by 3. So 1 by tc is 12 kilohertz, so 12 by 3 is 4, so 4 kilohertz. So fq2, the frequency of q2 is actually 4 kilohertz.